Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 6 from the Statistics S1 June 2018 International A-Level Edexcel exam. And this question here is about normal distribution. Now here we have a situation where we're told about the waiting times in L minutes to see a doctor at a health center is normally distributed, and it says the length of time is such that it's normally distributed and with a mean of mu and a variance of sigma squared. So mu stands for the mean of the times, and sigma stands for the standard deviation. That's what they stand for. It says, given that the probability that the waiting time is less than 15 minutes is equal to 0.9, and also that the probability that the length of time to wait is less than 5 minutes is 0.05, we've got to use that information to find the mean and the standard deviation. So that's what the question is asking us to do. So whenever we have normal distribution, we like to think about the normal distribution bell curve. All right, that will help us to understand how to deal with this question. So I'm going to get some nicely drawn ones ready for me. Okay, so now we have two situations. The first situation is the probability that the length of time is less than 15 equals 0.9. So I'm going to deal with that one first. So the probability that the length of time is less than 15 minutes is equal to 0.9. So if I was to draw the length on my axis here, where would the length of 15 minutes lie in this bell curve? Well, it's going to lie such that the area to the left of it, that the area less than it, is 0.9. Okay, so the area that's less than 15 is going to be 0.9. Now the total area of this whole thing is 1. The probability for the whole thing is 1. Okay, that's the probability for the whole curve. So 0.9 makes up the majority of the area. So that means 15 must be in such a place that to the left of it, most of the area of this shape is going to be. So 15 has to be somewhere on this side over here. 15 is going to be somewhere on this side. Okay, it's going to be somewhere on this side here. Okay, so that's where L equals 15 is going to be, such that the area to the left of it is 0.9. Okay, all of this area there is 0.9. Okay, let me just choose a color. So this area is 0.9. Okay, and if we look at the other situation that they gave us, they told us here for this one, the probability that L is less than 5 is equal to 0.05. So again, it's the area to the left of a number is 0.05. Now that means that's a very small area. It's, you know, if we're talking about the area, that 0.05 is very small. It's way less than half of the area. That means 5 must be somewhere over here on this side. 5 must be somewhere on this side over here, such that the area to the left of it, the area below it, is going to be 0.005. 0.005. That's the area, 0.05, sorry. That's the area to the left of it. So this must be where 5 is in terms of our L values. We're trying to find, one of the things we're trying to find is the mean. That mean is the same as this mean. We don't know what it is. Okay, we have to find, one of the things we have to find. All right, now, how am I going to use this information? Well, first of all, if we look at this one here, 0.9 is a nice rounded figure, right? I could find what this value of Z is. I'm trying to find what is the Z value, what is the standardized value. The standardized value such that the mean is 0 and the standard deviation is 1, which we're going to use the table for to help us find values of. But I could use this table over here to find what the value of Z is. So I can look for the area of 0.9. Okay, oops, going the wrong way. I look for the area of 0.9. Okay, this is the area. Phi Z is the area, and this is the area to the left of these Z values. So I could go to 0.9. Okay, it's over here, 0.9. The closest would be this, and I could write down the Z value would be 1.28. Okay. However, because we have a table here which has the probabilities with more exact values, okay, and these are the Z values such that these are the probabilities, not to the left but to the right of those Z values. I'm going to use this table here because both my values are values which are more exact. Okay, so, but the thing is, these Z values start from 0, just like they do here, and they go up to 1. All right, they go, well, more than 1. They go on the, basically they go on the positive side. They don't go on the negative side. Okay, and this one tells you the area to the right of the Z value. Okay, and what we have for the first question here, the first part, we have the area to the left of the Z value. So I need to know the area to the right of this value, and that area is of course going to be 0.1 because it's symmetrical. So this area here is 0.1, and that's the area to the right of the, this Z value. So I can use this to find out what this Z value is by using that small table, which I have a copy of over here. So if I take this and put it over here somewhere so I can see what's happening. So now what I'm looking for is the Z value of 0.1, which is right here. This is the Z value of 0.1. And this is the probability of 0.1, and not the Z value, I'm looking for the probability of 0.1, and the Z value, which is the value of Z such that this is the area to the right of it, is 1.2816. So here I'm going to put 1.2816. That's the Z value such that the area to the right of it is 0.1. So I've now found the standardized value for this first situation, and now I've got to do the same thing for the second situation. Now here again, we don't have Z values that go in the negative side. Okay, we don't have them. So here we know that this is the Z is equal to 0. This is the mean. Anything on this side, the Z value is going to be negative, below the mean. All right, we don't have any Z values that are negative, neither in this table nor in the big table. But I know that this is symmetrical, that if I folded this along this line, folded it along here, this area would be the same as the area over here. They would exactly overlap. They'll be the same area. So whatever this Z value is, this is the positive version of it. So if I find what this Z value is, then this is going to be the negative version of that Z value. So I want to find the area to the, I know the area to the right of this Z value is 0.05 because it's the same as that, because they fit over each other. So if I go to 0.05 now, I see I've got it on the table, and the Z value on this side is 1.6449. Therefore, the Z value that I'm looking for is negative 1.6449. And that's my Z value for this, and that's my Z value for that. And I can use those now to solve the problem, because I know that the formula for standardizing any score such that you can change it so that the standard deviation is 1 and the mean is 0, which what this Z value represents, is have the score that you're given to standardize minus the mean divided by the standard deviation. Now in this case, we have the Z value and we have the score. We don't know the mean, we don't know the standard deviation. So here the Z value is 1.2816. 1.2816. Okay, and that's equal to the mean, which we the X value, the actual score, which is 15, minus the mean divided by the standard deviation. Now that's going to lead me to an equation which is 1.2816 times the standard deviation, sigma, is equal to 15 minus the mean. So I can call this equation 1. And I can use this value, this situation here, I know minus 1.6449. Okay, minus 1.6449. Just be very careful when you're writing these numbers down, especially when there's lots of digits. It's very easy, for example, to write down 1.6499, and then your answer will be slightly off and you'll lose marks. So just, be very careful that you're writing down exactly what you see in the table. All right, some people have an issue with numbers like this and they start mixing them up, and you might lose marks, so be careful about that. Anyway, so that's equal to the actual score, which is 5, minus the mean over the standard deviation. All right, so if I rearrange that equation, I'll write it underneath here. I'm going to have minus 1.6449 times sigma, which is the standard deviation, is equal to 5 minus mu. So I have basically a pair of simultaneous equations. If I do equation 1 take away equation 2, I will get eliminate the mu. So this side is going to say 10, 15 minus 5, and the other side you're going to have 1.22816 take away, well, in fact plus, this is minus, I'll just do this, minus 1.6449. Okay, so that gives us 2.9265. That's 2.9265 times sigma equals 10. Therefore, we can say that sigma, the standard deviation, is equal to 10 divided by 2.9265. So we can say that sigma is equal to, we're going to do 10 divided by this answer. That gives me 3.4170, 3.41705. Doesn't specify, does it? It doesn't tell us to round it to any particular decimal place. So I can say, therefore, sigma is equal to 3.42. So that's sigma. That's the standard deviation. Now we've got to find the mean. Well, I can take, for example, this equation. I can rearrange it. So I'll say mu is equal to, I'll have 15 minus 1.2816 times the standard deviation, which I now know. So mu is equal to 15 minus 1.2816 times 3.42. I'll write it in I'll use it in its more accurate form. So what I'm going to do here, I'm going to take my calculator. I'm going to actually store this as A. So this answer is stored as A. And then I can say the mean, therefore, or the mean is going to be 15 minus 1.2816 times what I stored as A. Okay, and that gives me 10.6207. So we can say that the mean is equal to 10.6207 continuing. So to 3SF, it's 10.6. So there's the two answers for this part of the question. Okay, now what I'm going to do, in case I need this as well, I'm going to store this as B. Okay, so this is stored as B, this is stored as A in my calculator. Just write that down separately so I can remember that. So now that's the standard deviation and that's the mean. So we've answered part A. Now for part B, it says there are 23 people waiting to see a doctor at the health center. Okay, there's 23 people waiting to see a doctor at the health center. Determine the expected number of these people who will have a waiting time of more than 12 minutes. So we got to have basically 23 multiplied by the probability that the waiting time is greater than 12 minutes. That's it. So the probability of something times the number of people in the sample space tells you the number of people who fit that description for that probability in that sample space. So if there's 23 people, if I want to find how many people have to wait more than 12 minutes, I find the probability that it takes more than 12 minutes and then multiply that by 23 and it'll tell me the number of people who would be expected to have a waiting time of more than 12 minutes. So again, I can use my pre-prepared curve, all right? And I might need my table as well. I think I might need this table. Perhaps not. I'll just have it ready in case. Put it down here. Now, it says here 12 minutes. Now, we know already the mean is 10.6. So I know for sure that the waiting time of 12 is going to be more than the mean. Okay, it's going to be over here. This is 12. somewhere over here. And we want to find this area, okay, such that the probability that being late is more than 12 minutes, okay, is going to be here, right? So this is the probability that someone more than 12 minutes late, this area here, that's what I'm looking for. So I need to standardize my score of 12 first. This is the L value. I need to find what is this as a Z value, then I can use this table or the other table if I need to. So if I standardize the score of 12, I know, remember, Z equals X minus the mean over the standard deviation. So in this case, I want to find what Z is. X here is 12 minus the mean, which is 10.6, divided by the standard deviation, which is 3.42. So we can say Z is equal to, so let's in fact use the values that we have. You got 12 minus, put it like this, 12 minus, that's B in my calculator, so recall B, divided by the mean, which is 3.42, which again, it's stored as A, that one. Okay, so that gives me my Z value, which is 0.40365. 0.40365. Now, that's the Z value, okay, for this. And what I need to find is the area, which is to the right of the Z value. Okay, so the Z value here is 0.40365. Now, here we know the areas already. So in this thing, we're not going to be able to use this here because I'm looking for a Z value of 0.40365. I'm not going to find it here at all. So I'm not going to look at this table. I have to look at the other table. So let's go to the other table and let's just copy this so that we can remember the number. So I'm looking for the number 0.40365. Now I'm looking for a Z value for that. Now the Z values only come in 2 decimal places, so I'm looking for 0.40. I can't use anything more accurate than that because, you know, the Z value here is, you know, here is only to 2 decimal places. So I'm looking for 0.4. 0.4. The closest I can find to 0.40 is this. That's the Z value I'm looking for. That's the Z value that I have, and this is the area to the left of that Z value. Okay, so the area to the left of that Z value is 0.6554. Okay, so that means this area is 0.6554. So this area is 0.6554. If we look at our table, right? That's the table that we had over here. 0.6554. The area, remember this for this graph, it's the area to the left of the Z value that we are considering. The area to the left of it. Okay, so it must be bigger than, must be, you know, it must be over here, 0.666, what was it? Sorry, 6554. So now, what I need though is this, I need this area. Because I want to find the probability it takes more than 12 minutes, not less than 12 minutes. This would be the probability it takes less than 12 minutes. So what I'm going to do is, I know that this area is 1 minus 0.6554 because the areas have to add up to 1. So therefore, we can say the expected number of people, number whose the waiting time is less than, more than, not less than, more than, looking for more than 12 minutes, okay, is going to be this area, which is 1 minus 0.6554 multiplied by the total number in the survey, which is 23, and that should give us our answer. So if I do 23 times, and I put 1 minus 0.6554, okay, that will give us our answer. Oops, too many fives there. Yep, that will give us our answer, which is 7.9258. 7.9258, which we'll round to 3SF 7.93. didn't tell us how to round it. So 7.93, that is going to be the expected number of people who will have a waiting time of more than 12 minutes. 7.93. All right, so that's the answer to question number 6, A and B. I hope that was clear. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear in this region over here. Other questions from the topic of normal distribution from S1 in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch the video that will show up over here to find out how to navigate my channel in an efficient way to help you with your revision. Thank you for watching, and see you soon.